Hello, everybody. Welcome to Saturday Night SQL Virtual Chapter webinar. Can you guys see my screen? Okay, I'll share my. Thank you. All right, I guess you can see my screen now. Okay. My name is Sarah Huang. I'm the organizer of this virtual chapter. I'll be facilitating today's meeting along with our co-organizer, Debbie Huang. Today, Simon Cho will present building ETL efficiently with minimal logging. After his presentation, we'll have an open forum discussion. You're welcome to ask questions or provide answers to somebody else's questions. This meeting is purely for sharing knowledge with each other. Let me first go through a few things, then I'll hand over the reins to Simon. Why it's not working? All right. Past Summit Conference is from October 25th to 28th. And this conference has over 200 technical sessions, and it's a great networking opportunity with thousands of attendees from around the world. Our VC chapter discount code is VC15QVS7. You can use this code for $150 discount off the conference registration fee. At this point, everybody is muted. During our open forum discussion, you can raise your hand or type your questions out. I'll talk more about this later. Sorry. Okay. Sorry about the noise. If you would like to preview past summit sessions and speakers and get 24 hours of SQL Server and BI training for free, you can register at 24hoursofpast.com. You can see that. I haven't done that yet, but the website is already there. PAS stands for Professional Association for SQL Server, and it's sponsored by Microsoft. But it's a non-profit organization. PAS has many different kind of chapters. One big chunk is a local chapter, which has meetings, then everybody can meet. PAS also has virtual chapters like us that everybody can meet online. Here I listed all different kind of virtual chapters. You're welcome to join as many as you like, and of course you're more than welcome to join our virtual chapter, which is this one, Saturday Night SQL. All the memberships is free, and the good part is that once you join any or many virtual chapters, you'll get the meeting notification delivered directly to your mailbox. Our meetings tonight is Simon's presentation about the minimal logging, and in October, Peter Lu will come back and present what's new in SQL Server 2016 for SQL developers. And in December, Kathy Kallenberger will present indexing fundamentals. This is both all these topics are very popular and of course very important for data professionals. And here are some selected virtual chapter meetings, and you you can go to PASS website to get more detailed information. And this is the upcoming SQL Saturday events. And all these events are free of charge, and you probably just need to pay a launch fee, about $10-some. And PASS also, both PASS is mostly run by volunteers. Like in our virtual chapter, me and Debbie Huang, we're all volunteers, and so are all of our speakers. We really appreciate they spend their time to come over to present, share their expertise, their knowledge with us. And you may stay involved by joining PASS and get your free membership. Regarding to how to ask questions, like somebody asked earlier, there are two ways you can do it. First, if you like to ask your questions by yourself, you can raise your hand by click this little hand. Where's my mouse? Okay, here. By click this little hand sign, and then we'll unmute you, so you can talk. You may also type your questions on this side, this chat window. I'll read them out for you. And by the way, this meeting is recorded. We will post it on YouTube. For those of you who register for who are already our members, you'll get the notice from your email, and we'll let you know when we post the post the recording on the YouTube. Now I'm gonna transfer the screen over to Simon. Give me a second. Simon, now you may present, and thank you so much for coming back and share your knowledge with us. We can see your screen now.
Hello, can you hear me?
Yes.
Yeah, thank you, Sarah and Debbie. This is Simon Cho. I want to share the minimal logging operation, also the what's the best practice to build the ETL process. Here is my blog. I'm going to update my presentation and presentation file on my blog, and if you have any question, you can send me email. Also, I'm going to send this presentation to the Sarah and Debbie so that they can upload on the Saturday's NiceSQL website. Okay.
Great, thank you.
And first of all, this is a brief agenda, which is the we're going to quick review how to read the data. This is a little bit basic thing also included, and then we're going to see how we're going to pull the table, what's the with the example, and then I'm going to explain a little bit more about minimal logging. So I have just a quick question. Probably many people know about what's this term search, which is we call the searchable argument. Here is one question about I have one parameter, base account ID. So this is big int 1, and this is also big int 1. So query 1 and 2 is returning exactly same result, but let me see, where's my point? But this one has account ID, and then it's going to calculate it with this parameter plus 1000. This is the opposite way we calculate it and compare with the base account ID. So if this case, which query do you think is running more efficiency?
If somebody would like to answer this question, please raise your hand, or you can type your answer in the chat window. Just a second. Let me see.
Okay.
Yeah. Somebody said it's number 1.
Okay.
And also, have we got another vote for number 2?
Okay. Yeah, this is an easy example. Thus, suppose the query 1 is much faster because it's going to it's able to seek the index 6. The second one is basically SQL Server do not calculate this one at here. It go to calculate all the account ID minus 1000, which means the data is changed and then it's not able to do the index 6. So result is here. You can see first one is run index 6, second one is does the index scan and it's going to the key lookup. So the query cost is first one is 1%, second one is 99%. Let's look at the second example. This is a little bit different. I have query 1 that is similar with the previous one, but I'm going to compare like integer value like this, and then this another one is I have account ID with a varchar value. So account ID is a big integer in the table, and then query 2 cases I'm going to compare account name with a varchar value and with the integer value, and another one is account name and the varchar value. How about this? Which one do you think is faster, 1 or 2? The other 1 or 2?
All right. Anybody would like to answer? Somebody said 1.
Okay. Actually, the query 1 cases, there is no difference about performance itself. Obviously, somebody will say there will be convert will be happen for such as this kind of thing, but actually this one also happened the convert. And then because this is integer, this is big integer, and there is implicit conversion happen from the integer to big integer. This is a varchar, and then it's going to convert to the big integer as well. And we don't care about the one value converting cost. It's not a big deal. Compare with the table whole table size. The query 2 case is a little bit different. 42 cases account name, and this is integer, and this is varchar. Actually, this one is account name is going to convert it as an integer and compare it. And then second one is okay. This is varchar. This is varchar. So it's going to able to do the index seek. So here is the result. The first one is will show about 50%. If you see the detail about this property, we will see that both of them, the implicit conversions happen. And the second one is, as you see the previous one, this is what's that? It's compared with the integer with the varchar, and then varchar and varchar. So it go to the index C, but this is doesn't, because account name is going to convert integer. Do you know why this kind of things happen?
Anybody?
Yeah, I'm going to run a little bit fast because I have lots of slides.
Yeah,
So,
go ahead.
oh yeah, yeah, okay. So the so SQL Server has three things we need to consider when we use the index seek. First thing is a SQL Server search. So this is a searchable argument. I can't explain everything today regarding about this. So please look at this URL and then find out what's the search exactly. Basically, if a certain change happen on the index side, the column side, you cannot use the index seek. We supposed to read everything and then convert it or calculate it and then compare it. So that index seek is not possible. Index scan is only available. And then like column cases also is happen. So look at the size, what it is. And then the cast and convert, this is just one example. Which one can be heavier? Wait. Yeah, that's kind of right. The exact term is like data type precedent. In the SQL Server has the MSDN, they have the precedent of the data type, which one is going to convert in case of implicit conversion happen. So which means the look at the cast and convert, which one can be done by implicit conversion. And then this is very important. Probably not many people knows about this. So what is this data type precedent? SQL Server has a rule always in case of the implicit conversion happen, then it's going to disorder. So as you can see here, first one is user defined data type is highest one, and the SQL variant is the second location. Our scenario was the big integer here 15, and then varchar 27. So the varchar always going to convert to the big integer. Whatever location of the parameters there or the column is located doesn't matter. It's going to convert always from the varchar to integer. So one of the good example, we do the datetime. Datetime we usually provide by string. String is a varchar, and then it's going to convert as a datetime. Where is it located? Here, number 6. So it's going to try to convert implicit conversion to datetime. That's the one of the example I have, but this is might little bit different than you expected. So I had a register datetime with a compare with this string. In 42 cases, I do have the parameter and assign the same value. I run the select statement for this. Do you think any problem with this query? First of all, this one is running fine with index seek. probably I need to supposed to be change the recent data instead of like February. But anyway, first one most likely it's going to run as well with index 6. Second query doesn't. Most likely whatever value you put here doesn't matter. It's going to do index scan or cluster scan. The reason why the first query is we only looking for this value. Can you hear me?
Oh yeah. Sorry.
Oh, okay.
I guess it was my my web my connection.
All right. Okay. So second query cases, this is the declare and then datetime. And then when you compile this one, SQL Server will compile this query with unknown value. So SQL Server will make the execution plan with whatever value is coming and just give you the best performance. So instead, SQL Server will look at SQL Server. So in case of, let's say we have like 2-year data, saying 2-year data we want to see, or 3-year data we want to see, that kind of cases happen. SQL Server will do the what's that? The cluster index scan, because it need to read a lot of data. By the way, the register datetime is the non-cluster index. So here is the result. First one is going to do index 6 and then key lookup and get the data properly. The second one is the even we have the indexes there, it's going to read cluster index scan. This is missing index is coming because they want to including all the column. That's why the missing index is coming. So as you can see, the performance is a lot different. First one is 2-3 logical. It depends on the data, but the second one is basically reading entire table. This chart is regarding about case and convert the MSDN. You can look at this chart and which one can do the explicit conversion required, which one can do the implicit conversion required. Another one I want to explain today is regarding the index. There is a certain, how can I say that, certain priority to consider. So here is the one example. I have account ID, create datetime is deleted, first name, last name columns. And then I have the query is the first name like ABC and then person. And create datetime is between about year data. And is deleted is 0. And then same query, I create all of the index possibility, such as the first name is the leading column of the this index, and then second column is create datetime, and is deleted is the last one. And then this second index is first name or so, and then is deleted first. So all the possibility scenario, I create the index. Let's see the data is evenly distributed. Then if this case, SQL Server, which index will be chosen by SQL Server when we execute this stop row? I'm sorry, this is Edo query. Anyone can guess?
01, somebody said.
1, this one? It could be.
Yeah, NC0, somebody said. We got vote for number 5 and 6.
Oh, okay. Who was that? That's good. 5 and 6 actually can be chosen because is deleted is the only the one equal sign. The others one is range data like ABC plus something, and this is more than one record could be coming. This is also more than one record could be coming, but this is the only the equal sign. I know the is deleted is the bit column, and this is a really bad idea. Making the bit column on the leading column on the index. That's a really bad idea. But I just gave you one example. SQL Server most likely give the majority part about the equal sign. So here you can test this query, but most likely will show about 5 or 6. Depends on the first name and create name is depends on statistic. They're going to choose this one or this one. I already explained this one. Yeah. Let's talk about index access method. SQL Server has 3 index access methods, regardless is non-clustered or clustered. I thought everyone knows about first one, index scan or table scan or cluster index scan, something like that. But I don't care for now. This is a non-cluster or cluster, so I'll call this is the index scan. Second one, probably know everyone too. We'll say index seek. But inside of SQL Server, there is a 2 type of index seek. One is individual key lookup. Second one is ordered partial scan. So how it is different, and let me show you one of the graph about it. So regarding the table scan is basically reading entire index from the IM, from the start point at the end point. It's going to read everything on the leaf node and then do the sort or return the result. So this is index scan. The second case is index seek, which is an individual key lookup. So for example, I'm going to look at the account ID 100, 200, 300. In that case, it's going to seek 100 here, 200 here, 300 here. So it's going to seek individual value and look at the data on the leaf node page. Then what's the order partial scan is, it's going to do one seek at here, and then it's going to scan from here to here. It knows about the endpoint, such as I want to looking for the order date is 2006, February 12. So it's going to look at order date from here 12 until 13 is coming. So first thing will be seek is happen. So you find that the first of the record of order date is February 12, and then it's going to read until the next value is coming. So this is what we call ordered partial scan. Unfortunately, in the index detail page, the execution plan detail page, we can't distinguish this 2 or 3. Both of them show as index seek. And then this is combined example. So I'm going to look at order ID between 101 to 120. It's going to read 101 to 120 here, and then this is a non-cluster index. So I need to pull out less of data from the cluster index. So it's going to seek individual record and do the index seek like this in the cluster index. So this kind of individual seek is happen, and when you do the the bookmark key lookup or the index key lookup, those kind of things happen, it could be running like that way. Let's talk then what's the most efficiency method for the ETL process. basically I want to populate a certain amount, not just one or two records, then what is the best solution to use index scan or index seek with individual key lookup or ordered partial scan? Yeah, somebody probably think about number 2 or 3, or somebody will say 1 as well. The best book regarding about this information is the Ezek's book 2005, chapter 3. This is really good, so please look at that. For the ETL process, basically we want to pull the certain amount of data, so ordered partial scan will be the best instead of index seek. I mean the individual key lookup cases. But then what's the requirement? Let's look at what's the problem about the number 2 index seek cases. Let's say I want to make a 1000 duplicate record for my account ID. So that what I does, I create the one table, temp table, and account ID. I inserted account ID 1000 times. And then I do the join from account ID and temp table with account ID. If you see this one, the result, so the first query, this one, if you see the result, it's going to read the logical read 3000 times, which means even I'm going to hit account ID equal to 1 only, this one, it's going to read the same page 1000 times. So my purple read is going to increase like this much. I have an alternative solution to make a 1000 duplicate record. I create number table, and then I put the number from 1 to 1000. And then I'm going to do the join, and then I gave the where closer account ID equals 0. So it returns about 1000. It returns exactly same result of this one, 1000 record. This case, it's going to read only once and make a 1000 times duplication with number table. So that's the problem about index seek. I mean the index key lookup. So it could be really expensive if you read a certain amount of more data. Sometimes the index scan is much faster than index seek, individual key lookup. But ordered partial scan cases, usually it could be best practice to use the ETL process. So this is one of the results. It executed 1000 times cluster index seek about this case. The second case is going to allow only once with the account, and then it's going to make a duplication with the number table. Then what's the required for to use the ordered partial scan cases? It's supposed to be covered. All column is in the one index, and it's supposed to be ordered with the same criteria of my where closure and order by closure. Otherwise, data is scattered out, is random, so that I might need to do table scan or individual index seek. Then what should we do? Which one do we need to use it? To be able to decide this one, we need to understand about tipping point. Tipping point is really a big topic. This is the Kimberly presented in the Secret Best 2010 about indexing strategy. If you have the past 2010 session, please look at that one. She explained the tipping point like 2-3 hours. So basically what we call the tipping point is So how many percent of data, if you read a table, then individual index sig is faster or table scan is faster? Obviously, if you read only one or two record, index sig will be the most fastest one. But if you read like let's say half of the table, like 80% of the table, then index scan will be the fastest one. So that's the we call the tipping point. Then what percentage of the data do you guess about the tipping point? Can you answer for me, anyone?
20%, something like that.
Mm-hmm. Any other answer?
5%.
Okay, that's better. Actually, um, it's very different. First thing, so the Kimberly tested it 20 row per page and 100 row per page and 10 row per page cases. 1 million record. So 20 row per page means one page is 8K divided by 20 is about 400 byte 400 byte per 400 byte per record, right? This case is 80 byte per record. This case is like 800 byte per record. So if these three scenario cases, first thing was the tipping point 1.25, 1.66. Second case is 0.25, 0.30, 30%. And 10 row per page cases 12.5, 16.66%. Also, as I say, this is lots of dependency, such as system, performance, disk, memory, CPU, and index fragmentation as well. So no one can say exact number, which number, certain which number, then SQL Server will point, how can I say that? I'm sorry. No one can say exact number of the percent about the tipping point. It's very different. But generally I say it could be more than 1%, then table scan is better. I mean, you need to consider it, is it going to table scan or the index sig? And then no one does not do the calculation when you're making all the ETL process. So if you think like, oh, I'm going to read 1 year data, then probably table scan is faster. If you think I'm going to read like 2-3% data, then table scan will be faster. But also it's a lot depends of your system, but generally say if you more than 1%, yeah, you need to consider it. Then what is the main about tipping point? Basically index sig or the scan, we can talk about it. Also, bookmark is going to bookmark lookup or is going to cluster scan. So such as, for example, I have non-cluster index and then I have cluster index. I want to search by non-cluster index, but SQL Server keep trying to do the table scan. We see sometimes that kind of execution plan is coming. Could it be possible the data what I have the where closure, the data is too much, so that SQL Server is decided cluster scan could be faster. So that kind of thing we can think about. And here is the another one is about ETL process. Let's talk about we want to pull the delta data. Then it's 10% data I want to pull, but SQL Server cluster index scan is faster than SQL Server already pull 100% of the data instead of 10% delta. if there is a way to writing fast enough to the new table, that probably creating new table is much faster than sync the 10% of the delta data. Do you understand what I'm saying? So this is we can think about two cases. We're going to pull whole data instead of just delta, and then create the index and then foreign key relationship, whatever required. Or we can just pull the delta and insert to the table. That's it. So this tipping point, I can say about like 5 to 10% is a tipping point. If you pull more than 20% data, usually rebuild is much faster. So this is we need to consider about it. The reason why there is a way to make insert much faster than update. So here is one case. I create one source table, 1.5 gig table, and 20 million record I have. And then the target table I have one cluster index and 3 non-cluster index. I want to refresh this table with daily basis. And then for now, I'm going to use the linked server. So I have 3 methods I have. One is a drop cluster index, drop all non-cluster index, and truncate table, and insert target A, target B from source A, and create the cluster index, create all non-cluster index. Second case is I drop the table and create the table and create a cluster index and create the all non-cluster index, then insert the data. Second case is I do the truncate the table and just insert it, no change about index. Anyone can choose which method will be best. So basically, I want to pull 1.5 gig table. That's the 20 million record, and truncate and insert, and then drop and recreate. Which way is any method is fine. I just want to refresh the data daily basis.
Yeah, we have one. Somebody choose one. Somebody choose.
Okay.
Somebody else choose two. So.
Anyone has better? Can explain?
From 1 to 3, I guess everybody, it's all over the board.
Okay.
So for number 3, though, I'm just ask a quick question. For number 3, if you just truncate the table and insert, are you gonna lose the non-cluster index?
No.
You don't. All the indexes are still there?
Yes.
Oh, that would be the best.
It could be. Let me explain a little bit more about current issue. The first thing is you please understood, we shouldn't drop the cluster index first if there is non-cluster index is there. When we drop the cluster index, all non-cluster index is rebuilding, because in the leaf node of non-cluster index has cluster key. When you drop the cluster index, means we need to remove all the non-cluster index key on the non-cluster index, and we need to point it new location of the heap, which is bookmark ID. So this is really a bad idea. Drop the cluster index and then drop the non-cluster index. Okay. Frank Wayne said drop table, then load, then create index is best. Yes, actually, I have 3 more methods.
Oh.
So truncate table and drop all non-cluster index, drop cluster index. So this is the correct order. And then insert data with table up. And then create the cluster index and create all non-cluster index. Truncate table, drop all non-cluster index, and I do not touch cluster index. Cluster index still is there. I insert the data with table log and create a cluster index after this. 6 is the drop table, select into cluster index, and then create a non-cluster index. Okay, there is a lot of answer. Okay,
Yeah.
that's good. Yeah, let me explain a little bit more about this. I have only 15 minutes left. The first thing is method 4, 5, 6. All these three methods is we can do the minimal logging. The method 1, 2, 3 cases, it could not do the minimal logging operation. So here is the result about number 1 to 6. So number 1, and I just make a group because these two, if I have the group like this, that means 3 of them has similar the performance. That's why I just make the group like this. So I have simple recovery mode, bulk recovery mode, full recovery mode. And then method 1 cases, it took 23 seconds and log count is coming like that. Log ranks is coming like this much, but how much log ranks is 183 megabyte. And then 2, 3 cases, kilo megabyte, 562 megabyte. 4, 5, 6 cases, 2.3 megabyte. So log generated is much, is changed a lot. When you use minimal logging operation, there is most efficiency one. The compare is I just make this number is unique, my unit. So I put this one as a 1, and this is 80 times more. And second one is 2, 3 method is 50 times more. So as you can see here, simple and bulk recovery mode, they are look at similar operation. This is a little bit different, but that much there is not that much difference. So that I just put as a same unit number, and then 80 times expensive, 250 times expensive. Full recovery mode cases a little bit different, but still 2, 3 is a slowest one. 4, 5, 6 is the fastest one. How I check the log lengths? I land this statement, count log record, the log record lengths, some log record lengths from the function db log. So maybe someone say my task is wrong because the SSA package is much faster and there is no reason for you to use the linked server. I tested linked server as well. Show me same result. I'm sorry, I tested the SSA package as well. It showed me same result. Nothing difference. So, and somebody might say the duration is not that much difference if you didn't catch about duration. So 4, 5, 6 is 11 seconds. 2, 3 cases 27 seconds. This is 23 seconds. So duration is only different like 2.5 times, less than 3 times. So I tested on my USB disk because my laptop was SSD. And then I tested on the USB external disk. And then we have I just tested the slowest case and the fastest case. I received the similar information. The only difference about 3 times duration difference. Log length is changed. Well, generally I say you can see about improvement about 5 to 10 times when you use using the minimal logging. But somehow when I test my laptop, it doesn't show that number. And then in my experience, we have a 24 hours big ETL process was taking about 45 minutes. So you can test it about it. But if you see the number about between the fastest and slowness, so physical light was happen 7.9 gig for the slowness method, and physical lead is happen 5.5 gig for slowness method. CPU time, and then logical lead, which is this much buffer pool, is 4 terabyte. And then this is a result I have. I just do the 1.5 gig data, and it's going to increase my LDF file 19 gig. So it's going to use 19 gig. And the second one, which is the fastest method, only used 420 megabyte. So 8 times more log created on the disk, and 6 times more CPU, 1.5 times read, 2 times write, 250 times the buffer fully this happen when with the slowness method compared with the slowness and fastest method. So minimal logging operation does quite good job when you use it. This is 1.5 gig table only. Do you feel like this? If you didn't know about this? So let me explain about the minimal logging a little bit more. What the minimal logging operation does, in case of the full logging operation, everything logged by row level. It's not on page level, even that it's not on extent level. Every single row is saved on the LDF file, inserted, deleted, updated, whatever operation is happening. But minimal logging operation cases, it does not save all data. It's going to save only enough to roll back information, and then extend the allocation information only. So it does not have like any each of the row inserted, deleted, something like that. It only has extended, allocated, deallocated. Those kind of information is saved on the LDF file. So that's why minimal logging operation can be much faster. And then for recovery mode cases, is actually there is improvement from 2008. It does save the page level data so that we can roll back the data. When you use a CDC and replication, we can't use it. And then to be able to use the minimal logging operation fully supported, we should change the data recovery model to the simple and bulk. Frank Wayne asked about simple bulk full recovery mode. I'm going to explain a little bit later in the next presentation file. So basically, SQL Server has 3 different recovery model. First one is a simple, and second one is bulk, and third one is full recovery model. When you create a database, the basic operation is run by full recovery model, but we can change it to the bulk or simple. Okay. So what can be the minimal log? Select into, bulk import, bulk insert, BCP, and create alter drop index, insert into with a table log. Table log is very important for the minimal logging operation. Obviously, not many developers like to have the table log. Basically, it's going to blocking other update and insert operation for that specific table. And then read committed cannot read the data and dirty read is okay with a NORAP. Yeah, that kind of limitation is there. But um, actually, many people already does with the SS package. When you see the SS package, the default parameter is going like this: table lock and check constraint. So that's the default parameter in the SS package, and then many people probably use just as it is when we insert the data. So yeah, you need to consider the table on how it's going to affect your application. But if it is okay using the table log, minimal logging operation will be the one of the choice. There's a lot of prerequisite. I have the summary of this requisite here. So we have heap and no index, and then in the table we have the data or nothing. At the time when you use the table log, then this operation can do the minimal logging operation. We have a heap, and we don't need to consider all these are actually, because this is all full logging. Only these two can be do the minimal logging operation. So which means when you insert the data to the heap, we shouldn't have any index. And then there is a data or nothing, doesn't matter. In case of a cluster index, we shouldn't have any non-cluster index to be able to use the minimal logging operation. And also, cluster index case, it's supposed to be empty. When you, if there is already data and we want to insert it the cluster index, then unfortunately it does full logging instead of minimal logging operation. Please look at the detail about this or this MSDN for minimal logging operation. And here is the Frank Wayne's question. This answer for we have the three recovery mode on the database. One is full, and then simple, and bulk log. Many people know about full recovery mode, which is default value. This is a log. Everything logged, and then we need to do the two backups. At least two backup we need required to performing. One is the full backup, and second one is log backup. So log backup is very important. Simple recovery mode cases, somebody is understand about simple recovery mode doesn't have any log. That's wrong. Simple recovery mode has a log because without log, SQL Server could not roll back the transaction. So simple recovery mode cases also we have a log. But once a transaction is committed or rollbacked, and when the checkpoint is happen, then log is reclaimed the space. So it's going to automatically shrink the log LDF, not a file size. Inside of the LDF file, it's going to make a free space and use it again. The file size doesn't change it unless we do manually change something. So simple recovery mode cases, we don't need log backup. And this is a fully support minimal logging operation. Bulk log is only for minimal logging operation requirement. Log backup is required. When the SQL Server has a bulk logged recovery model, actually, if you're not using any minimal logging operation, the bulk log is actually exactly same as full recovery mode. It's going to save all the data on the LDF file. But only difference about bulk log, when the minimal logging operations happen, then bulk recovery mode understand about minimal logging operation, and it does the same. It's going to fully support the minimal logging operation, which means it's not going to save any low data change, and it's going to save only extended level of the change. So log backup the log size is not going to increase a lot, and the minimal logging operation case has same performance of the simple and bulk log. One thing is, remember, once the minimal logging operations happen in bulk recovery mode, then LDF file has only extent level of a change, and next log backup is going to back up all the extent level of the has been touched by minimal logging operation. So the log backup size is much bigger than before. Most likely almost same size with full recovery mode. And then we need to understand a little bit more about bulk recovery mode. This is designed for the protect against the media failure. And then normal transaction, as I explained already, is same as full logging transaction, full recovery mode. But minimal logging operations, it does the best performance, and then uses the least log space. LDF file doesn't have full transaction log, which means we can't do point-in-time recovery. So point-in-time recovery is not available, such as when you restore the database, log, we can put the stop at what time frame I want to see the data. This kind of thing is not available. We need to restore all of the LDF file, and then log backup will contain the whole page and extent data by touch the minimal logging operation. So the size of the backup size almost same as full recovery mode cases. Please look at detail of these MSTN. And yeah, if you see that there is a list, and I think it's worse, because this is not such as, for example, we want to do the reporting service on the secondary machine. So we pull the data every night from the production to the secondary machine, and then we show data something. So which means if you lose, by the way, this or the recovery mode change, we don't need to, in this case, we don't need to touch the production server, because production server let it run as a full recovery mode. Only the secondary machine, which is the target server, we need to change the bulk recovery mode, which is insert the data. So I think this kind of case we are okay with bulk recovery mode, and then we can since we can make a way better performance for this case. You can test it about it. And in the production server, I do use as well when we do the index rebuild operation. Like when you run the index rebuild operation, LDF file can be increased a lot, and then it could be take a lot of time, like 10 hours, 12 hours, something like that. It depends on the database size. But you will see lots of better performance when you change to the bulk recovery mode temporarily on the production server, and then rebuild the index, and then after finish, change back to full recovery mode. So during this operation, there is a possibility of the point-in-time recovery is not available. Please understand. But the performance time is much faster, and then usually the night job cases we can it depends on the business and their operation, but there is a trade-off. So we can consider about the bulk recovery mode change on the production server as well. Yeah, that's what time is it? 1 second. Let me quickly. Yeah, time is already over 1 hour. Let me quickly give you one more example. there is one more introduced about trace flag 610. So what's the 610 is we cannot, many of cases we cannot use the minimal logging operation, but after trace flag 610, when we insert the data by the same order of the table or index, then the padding part can be do the minimal logging operation. So please look at the detail about the website. And then here is one of the summary. When you use the trace flag 610, so for the original minimal logging operation was index, heap, and with a table log, and then we can do the minimal logging. It's same does with trace flag 610, but here is a one advanced option: heap plus index. I have index, and with table log, if that case, trace flag 610, it might do the minimal logging operation too, such as but has a depends, which means insert data order should have same as index order. If it is, then we can do the minimal logging operation. Also, closer index, there is a lot of improvement. Empty without table log, with table log it does already, but without table log can be the minimal logging operation. It was a data, and we can do the minimal logging operation. With the table log, with the data and table log, it could be done with minimal logging operation. These two cases most likely not usable because cluster index and non-cluster index should have the same order of the index. At that time, you can do the minimal logging operation. So, but this is not always possible because the inserted data should have the same order of the cluster index or index, so that it could be possible or sometimes not possible. So my recommendation is if we can use native minimal logging operation instead of using the trace flag, please try with that. If it is not an option on your environment, you can try with trace flag 610. Obviously, you need lots of testing for this. That's all my presentation today. Yeah, do you have any question?
If you guys would like to ask your question, please raise your hand so we can unmute you. Simon, I think there are some questions somebody mentioned earlier.
Okay. I thought I already answered that one. Regarding the minimal simple bulk flexible, right?
Yeah. So that one from Frank. Okay, maybe I remember it wrong. Well, this probably. Well, I guess we'll do that later. Let's see if somebody else has questions first.
Okay.
If you can't, talk, you can type your questions in the chat window. Oh, I guess you did a great job,
Okay,
Simon.
cool.
Yeah, thank you so much for the great presentation. That's very informative. How about we start our open forum session and we
Okay.
yeah. There are a couple of questions that you may be able to help. I think I emailed you about this earlier. Is it possible for you to maybe briefly talk about the permissions. For example, if you say build a new server,
Mm-hmm.
and then you have to grant the end users permissions, say like to run packages or
Mm-hmm.
to publish SSRS reports. What kind of permissions does one need in order to run SSIS package using the proxy account and things like that?
Um, there's lots of question I have about that question because it depends on the how operated internally. So for example, if SS package is going to save the data on local folder, then we should have the same structure of the local folder and have the proxy account permission on that folder. And then the proxy account is going to connect another SQL server, and that SQL server does not migrate it, or it just stay there. Most likely, we don't need to change any permission on that. But if the proxy account is going to use like link the server after logging the machine and come to back to the original source, then we need the proxy account on our new server as well. So basically we can think about the proxy account is the user who is executing the SS package. So every component is going to hit the proxy account permission is required.
Okay, so I remember somebody said, say like you use Windows account as the authentication.
Mm-hmm.
If I remember correctly, they said you can set permissions at different levels, say like Windows level or even OS level. For say like SSRS, you grant somebody pretty much the full permission so that they can not only publish reports but also manage, like granting somebody, assign somebody else in different kind of roles and things like that. Does that require some kind of special permission, say like at Windows level or OS level even?
Actually, that's just I don't understand exactly your question because the OS level permission and window level permission actually what I think that's the same permission, which is domain account permission.
Okay.
So yeah, OS level permission, I don't understand what you mean about OS level permission. I thought once we create a domain account, that domain account can have the permission any location, right? So um and so I think are you talking about like a coverless authentication, or if it's that scenario, we might I thought we can discuss a different one. I don't know how I can answer for that.
Okay, no problem.
Yeah, and yeah, for the SSRS cases, there is the different permission. This is not a SQL Server permission. The SSRS, you I thought you are talking about the browser permission or manage permission for the report. Um, that one is doesn't care the how to connect to the SQL Server or the data. It's because the connection this connect to the SQL Server, we need to set up a special, more likely different user and the password on the connection string level. But SSRS only to the managing the report perspective.
Okay,
Mm.
thank you. Well, we have this is for everybody. We have a big surprise, and Peter had a surgery earlier, but he's here tonight.
Okay.
Yeah, well, somebody asked some questions, and he has the answer. Peter, would you be able to talk at this point so that you can rest?
Yeah, I had a surgery this morning, 10 o'clock, but pretty good. It's like a micro insertion surgery, so pretty good. I wanted to talk because if I missed this opportunity, then maybe Lisa, right? Lisa will wait for another month. It doesn't make sense for her.
Yeah.
Right? So how do I share my screen?
Just a second. Let me transfer screen over to you.
Okay.
Sorry.
Okay.
Yeah, I think we can see your screen now.
Okay, good. Okay.
Yeah.
So the first question I received is about, maybe sequence is wrong, is this Excel document, right? We have these warehouse locations. The logic is, if this empty, use the previous one, right, Lisa? So what I did was I defined the policy formula, say, if this guy, I add a column. First, I add a column. Then if this column, your B column is empty, I use my previous column, previous row. So if B3 is empty, I use B2. Otherwise, I use B3.
Oh, okay.
Then I just drag this formula all the way down, then I get it. Then when you import that database, you import those columns, you will forget about this column.
Sure, that's, yeah.
Simplest thing to do. However, I figured that there are some like dirty data here. So like 130 bucks times 6, all that will cost per bound. You need to clean up your data. I did clean up the data, then I load it into the database. It works. Okay, this is the first question. Anybody have any questions on how to do it or where to do it? What's the logic?
I don't know what he's talking about.
You know what I'm talking about? Okay, let me try again. Okay, let me start over again, right? So
we have a Chinese social media tool that we gather a group of people in that group, and somebody asked a question, Peter answered, and I asked him to present over here so that more people can learn from it. That's why.
But what if the data, excuse me, what if the data is more than like 2 million, 3 million? It's kind of hard to manage on the Excel file. I thought it's better to create the one query to look at the previous order if the data is really big. If data is small, I don't care. We can do the manipulate the data and insert the data, insert the table. But if data is quite big, it could take a long time to generate this kind of the final set. So probably we can add a sequence number when we insert the data, and then based on that table, we can create a relationship table like from sequence A to certain number is using the warehouse ID with this one, and then sequence number from where to where we can use another ID, something like that. We can make another relationship table, and then we can join together and then create another table or make a store procedure. I thought we can do that kind of approach.
Yeah, that's another way to resolve this. So maybe you can do some kind of lookup or something as well.
Mm-hmm.
Yeah, Peter just got offline. Oh, he's
Sorry,
back.
I'm back
Oh,
now.
you're back. Cool.
Oh, okay.
I'm back now. My machine crashed.
Oh, okay.
Um,
I mean, if you have some topic to talk, go ahead. Continue with the topic.
no, you can go ahead. Would you like to
Get a screen.
talk about the second question somebody
Okay.
asked?
Okay, second question. Let me share. Can you let me share the screen?
Oh, okay. Yes, we were still looking at your previous one, I suppose. Whoops. Why? Let's see. Make you presenter.
Okay.
Yeah, we can see a screen now.
Okay. The second question is that what happens if my boss really want to do it in database? I don't want to do it in Excel, right?
Mm-hmm.
So my answer was, sure, you can load data to the staging table, then you use the store procedure to massage it. Then the question is, how do you do it in the, then I said cousin, right? So, okay, write a example to show me how to do cousin, right? So this is my database. I have two tables. One is called inventory staging, one is called inventory, right? The inventory staging table, you have all the columns you have plus one identity column. The reason I have identity column is I want to maintain the position of the data in this Excel in my table in exactly the same. I did this in the beginning. I didn't have this column. Then I got trouble because the data moved around. So then my logic doesn't work anymore, right? Then I have another table called inventory. That inventory table is the mirror of the inventory staging, but no identity column with all the warehouse other stuff, right? So that's all the table definition. Then what I did was I used this task import, then choose the Excel, then get the file, then load the data in, blah, blah. So now you can look at my staging table. It's exactly the same as, oh, this is master. It's exactly the same as you have in your Excel document, right? Of course, I cleaned up your data. I don't have those dogs or time or that stuff. So those are the right data, right? So then look at the logic. I mean, I didn't put a store procedure, but I put a query here. You can put all those query into a store procedure, you have it, right? So I declare the location variable, F2 variable, UBC variable, credit, blah, 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 or the record ID, all the data points, right? Then I need to maintain another variable called previous location, right? Then before I do anything, I'm going to delete everything in the inventory. Right now, I do have data in the inventory. Let me show you. See, right? Good data, right? So I'm going to, in my logic, I'm going to delete it. Let me delete it first so that you see that there's no data there anymore, right? Then you come here, select, nothing, right? So when I run this thing, the data comes back. That means my logic works, right? So what I did here is I declared a cursor as select from the inventory schedule, right? Then I open the cursor. I open the cursor. Yeah, right. Then after opening the cursor, I fetch the first row into all those variables, right? Then I say I put a loop here. Why fetch status equal to 0 means you haven't reached the end. I have a beginning end here, right? The magic is these two lines. The rest are just nothing. Say if location is none, I set location equal to previous location, right? So now my location always have data because the first row has the location. Then I insert the data into inventory using all those variables. Then I fetch the second one, the following one, then take the loop, right? It's not too complex, right? Then by end of it, you close the inventory, to close the cursor, you deallocate the cursor.
Yeah.
So
Cool.
let me run it. That. Original one still there. The staging is like that.
That's pretty fast.
Yeah. I mean, you only have 100 over 180 rows. Not big deal. Right. So these are the second question. I think that's another question they asked about how to do the querying and instead of too many alls. I don't know who asked that, right? I do have that example as well.
Wow. Wonderful. This is a bonus.
In operation, okay. So there's a project. I have another database called Cometrics. This is my own database I use for purpose. So this Cometrics database have a table called project master. If you look at the project master, I have a project key. I have a simplified project name. So I have two project names, right? So then in my Cometrics, I have a project here, right? So then what I want to do is that I want to search for Cometrics if in the Cometrics the project is either equal to the first project or simplified project, right? I can say C project equal to PM project or CM project equal to PM simplified project, right? But I didn't do that. I just used in. Remember, I suggested in the WeChat, I said you can try in. I haven't tried, but I thought could. Then I tried this. So let me show you my. Oh yeah. That. So basically, what I tried. This is my answer to your three questions. I will ship this code, like packed to like a zip file. I send it to Sarah.
That's great. Thank you so much. Hope this didn't give you too much trouble while you was doing.
I did this before. I already done it. I told you, right? In last Thursday, I already done it. Then Friday evening, I got this episode. Saturday morning, 3 o'clock, I was admitted to the emergency room. They told me I need to do surgery.
Oh boy. Yeah, that was really scary, especially at night. So hopefully you gonna recover pretty soon.
Pretty good, pretty good. I think I will be discharged tomorrow.
Oh, wow. Okay, thank you so much, Peter. While still in the hospital and to the helping us resolve the issues. So anybody has questions?
I remember I heard one of the members said, didn't understand this Excel thing. Let me try to do the Excel again.
Okay.
It won't take a minute.
Oh, no problem, no problem.
So let's say I delete it, right?
Mm-hmm.
Nothing. Yeah, no, that's fine. Yeah, actually, nothing. I can delete it. Right. Mouse. Right. Because I'm in the hospital, I didn't have mouse. That's just my mouse pad.
Oh.
Right. Nothing here, right?
Mm-hmm.
So what well, of course, it's putting the question for you. Another observation is that I noticed that you have some Chinese here, right? It's
Right.
better not to involve Chinese in the columns. Sometimes it may not be good. So the first one I say equal to this guy. Okay? Then the second one I say I do this fx. This fx say choose the most frequent one, which is right. So if in the logic is if this guy equal to none, then you say I want to take this. Otherwise, I want to take this. Right?
Mm-hmm.
Pretty straightforward, right? Now I drag this formula all the way down. That's it.
Peter, I think Simon asked about this earlier. If this is for a small number of records, what if it's like millions?
Give me a number. Millions, right? Okay.
Yeah, say
Let
like
me,
a million.
let me tell you this column matrix. What's the columns, the row, how many rows? Oh, this is small. This is my own database. In my production database, this one was 2 billion records.
Wow.
And this code matrix, this code matrix was imported from Visual Studio. Visual Studio produced the code matrix. I copied it to Excel. Actually, you can open it in Excel. Then do this massage, load it to this database. So Excel, I mean, pretty good.
Were you able to export this much data to an Excel file?
Excel
In
file,
billion?
yes. Excel file can control more than 1 million records after 2007, but I thought many people understand about if we handling like 100 meg, 1 gig Excel file is kind of really challenging to open it to Excel file and manipulate the data. So I think it's better way to import the data to the SQL Server and then make up
Yes,
another approach.
I agree.
Yeah, and then uh, in my suggestion, actually, instead of using the cursor, the save the data about min-max value of the each warehouse ID, and then based on that table, we can join by the sequence number with find out the warehouse ID.
Yeah, you could do that as well. I
Yeah.
mean, this thing, you see, look at this thing. This thing's supposed to be one-time deal, right?
Mm.
So it doesn't matter. You can massage data one time go. So
Okay.
you don't really need to think of too fancy way add some new database structures or add more tables out there. This is typical case, the ETL or data basically you can
Okay.
run.
Yeah, yeah. If you guys have time, I would like to ask one more quick question. Does anybody or you guys have the experience to grab data from the SharePoint site, not the SharePoint list or view, but just Excel file sitting on the SharePoint and grab it and import into a SQL Server database using SSIS?
I think the better way to do this will be, okay, let me back off a bit. You will be surprised. Everything in SharePoint are in database. It's a big, like a flat database. So if you get a hold of the back-end database of the SharePoint, basically you can do anything you want.
That's true, and that was the problem. They do not have allow us to access the backend database.
I see, I see.
Yeah, and I tried OData and also tried there's like some kind of adapter I tried but didn't work.
How
So
about this way? If you leave the SQL Server aside, right? Don't do SQL Server. You go and use the SharePoint API, write some C# code, pull the data, and put it in the SQL Server.
yeah, it's yeah, that'll be an option and just need some time. Yeah.
Okay, let me share with you this. In just a preview. Remember I said I'm going to show you that always masking, right? The always encryption and masking, right? That always encryption, it doesn't work if you use SSMS. You have to write C# code.
Yeah, because otherwise it's a security concern, right?
Yeah, yeah.
Mm-hmm.
So sometimes you got to write some code.
Yeah, yeah, I guess. All right, great. If nobody has any additional questions, I think we'll stop here. It's already 10:40 on my end. Thank you so much, Simon, for coming back and share your knowledge again. This is a great session, and we really appreciate that. Also, special thanks to Peter, present and help us to resolve the issues. You know, while you're in the hospital, just had the surgery. So that's, yeah, we don't know what to say except to really, really appreciate that. Thank you so much. Thank you everybody for attending this session and ask great questions and also answer questions. Thank you everybody. I hope to see you in October. Peter Lu will come back and present, like we said before, the 2016. Let's see.
Thank you very much, Sarah and Debbie and Peter.
Thank you very much. Pleased to work with you, everybody.
Yeah.
Thank you.
Thank you.
Oh, thank you.
Okay. Bye.